The left boom still had paint on it, olive drab, flaking in long strips where rain and frost had worked the aluminum for months, maybe longer. A French farmer found it in the spring of 1945. 2 Allison engines half buried in soft earth near Colmar, the twin-tail assembly sheared but recognizable, that unmistakable fork-tailed profile pressed into the mud like a signature nobody had asked for. The cockpit nacelle sat 30 yards from everything else. Whatever hit this P-38 had separated the pilot's world from the machine's world in a single violent second. The farmer left it alone. Allied recovery teams tagged it, cataloged it, moved on. One more wreck in a continent full of them. But this particular heap of bent metal has a story behind it. Tucked into the postwar Foreign Military Studies collection, manuscript B309, filed by a Luftwaffe Gruppenkommandeur who'd flown Messerschmitt 109 G6s along the Franco-German border in late 1944, sits a passage about an engagement that lines up almost perfectly with the time, location, and circumstances of this crash. The German officer doesn't name the American pilot. He doesn't celebrate the kill. What he describes, in flat bureaucratic prose, is the 4 minutes before the kill, the part where he chased a lightning in a climb from 14,000 feet toward 28,000, and watched the American pull away from him like he'd shifted into a gear the Messerschmitt didn't have. The German's engine started cutting out around 23,000 feet. Manifold pressure dropped. His wingman's canopy frosted so badly he broke off entirely. The P-38 kept climbing. The German officer uses a word his translator rendered as effortless. That's his word, not mine. The American kept going up, and the 109 couldn't follow. So the German did what any competent fighter pilot does when the vertical fight turns into a losing proposition. He waited, circled at his own ceiling. Let the American come back down, because eventually everyone comes back down. And when the lightning descended 20 minutes later, alone, possibly low on oxygen, the Messerschmitt was sitting at 19,000 feet with an altitude advantage and a full charge of 20mm cannon. The rest of the story ended in that field near Colmar. A lot of this history sits in archives most people never touch. If you want to see what those files actually say, and what the Luftwaffe admitted when they thought nobody outside the US Army would read it, hit subscribe so you don't miss it. Drop a like if climb rate matters more than top speed. And if you know a detail about P-38s in the ETO that contradicts anything here, the comments section exists for exactly that reason. The German pilot got his kill, but read the report carefully, and the victory isn't the point he's making. The point he's making, across 3 pages of dense tactical assessment, is that the engagement should never have required 20 minutes of waiting. A fighter pilot who has to orbit at his own ceiling while his opponent occupies airspace above him has already lost the initiative. He won the engagement and lost the argument. His own report says so. The Messerschmitt 109, in every variant from the Friedrich through the late-war Karl, could not sustain a climb rate above 20,000 feet that matched what the twin-engine Lockheed delivered as a matter of routine. Not in comparable conditions, not at comparable weights. The supercharger staging on the Daimler-Benz 605 engine gave the 109 a hard ceiling that dropped further every time the Luftwaffe bolted more armor, more guns, heavier radios, more field modifications onto an airframe designed in 1935. The P-38's turbo-supercharged Allisons, and this is the technical core we'll crack open later, maintained manifold pressure at altitudes where naturally aspirated and single-stage supercharged engines turned into expensive paperweights, just as the B-29's pressurized cabin let American crews work at heights that turned Japanese interceptors into gasping, stalling targets over Tokyo. The P-38's turbo system let a fighter, not a bomber, a fighter, own the air above 25,000 feet in a theater where the Luftwaffe had built its entire tactical doctrine around altitude advantage. The Americans took the high ground. The Germans noticed. What happened next is the part that matters for this story. Because German pilots didn't just lose individual engagements in the vertical, they changed behavior. Unit-level tactical reports from Jagdgeschwader 26 and Jagdgeschwader 2, the 2 fighter wings that bore the heaviest burden against American fighters over France and the Low Countries, show a measurable shift in preferred engagement altitudes across 1943 and 44. The trend moves downward, not because German pilots suddenly preferred low-altitude dogfighting, because the high-altitude fight had become a place where the P-38 could dictate terms and the 109 could not. To understand how a single American design decision, bolting exhaust-driven turbo-superchargers onto a twin-engine airframe that half the Army Air Force's own pilots initially hated, forced an entire enemy air arm to abandon the altitude band it had dominated since Spain in 1936, we need to go back to a Lockheed engineering office in Burbank, California, late 1937, where a man named Kelly Johnson made a choice about engine breathing that would reshape the geometry of air combat over Europe 6 years later. The frozen air above 25,000 feet belonged to whoever could breathe up there. Johnson made sure the Lightning could. February 11, 1937. A document lands on desks at Lockheed, Curtiss, Bell, Vultee, and a handful of other airframe manufacturers across the United States. Circular Proposal X-608, issued by the U.S. Army Air Corps, Lieutenant Benjamin Kelsey's fingerprints all over it. The requirements read like someone made a typographical error and nobody caught it. Interceptor, single seat, maximum speed, 360 miles per hour at 20,000 feet. Time to climb to 20,000 feet, 6 minutes. The 6-minute number stopped conversations. In early 1937, the fastest pursuit ships in the Army's inventory, P-35s, early P-36s, needed closer to 9 or 10 minutes to claw up to that altitude, and they arrived wheezing, their engines starved of the dense air they'd left behind at sea level. 6 minutes to 20,000 feet meant sustaining a climb rate above 3,300 feet per minute across the entire envelope. For a single-engine fighter carrying guns, ammunition, armor, fuel, radio, and a pilot, the math didn't cooperate. Most histories skip this part. Kelsey didn't write X-608 because he wanted a faster airplane. He wrote it because he wanted an airplane that fought well at altitudes where existing American fighters turned sluggish, and European fighters, the 109, the Spitfire, the Duoitine 520, already operated with confidence. The altitude problem had a simple cause and a brutally complicated solution. Air gets thin. Engines burn fuel by mixing it with oxygen. Less oxygen, less combustion, less power. At 20,000 feet, ambient air pressure drops to roughly half its sea level value. An engine rated at 1,000 horsepower at takeoff might deliver 550 at 20,000, maybe less, depending on temperature, humidity, and how optimistic the manufacturer's brochure had been. The Europeans solved this with mechanical superchargers, gear-driven compressors bolted to the engine, spinning off the crankshaft, cramming extra air into the intake manifold. The Rolls-Royce Merlin used a single-stage, single-speed supercharger in its early marks. The Daimler-Benz 605. A powering early 109 Emile variants used a similar arrangement, effective and compact, with a long service record, also limited. A mechanically driven supercharger consumes engine power to produce compressed air, parasitic loss, engineers call it, and a single-stage unit hits a wall. Above a certain altitude, the compressor can't spin fast enough to compensate for the thinning atmosphere, and power falls off a cliff. The Merlin's critical altitude in 1939 sat around 16,000 feet. The DB6-05, roughly similar. Above those numbers, every additional 1,000 feet of altitude cost disproportionate horsepower. Kelly Johnson knew all of this. 27 years old, already Lockheed's chief research engineer, a farm kid from Ishpeming, Michigan, who'd worked his way through the University of Michigan on a scholarship and joined Lockheed in 1933. The company had nearly gone bankrupt twice. It built passenger planes, not fighters. Johnson had never designed a military aircraft. None of that seemed to bother him. His answer to X-608 threw out the European playbook entirely. 2 engines instead of 1, Allison V1710s, the only liquid-cooled engine General Motors' Allison division produced in quantity, each rated at 1,000 horsepower, and on each engine, an exhaust-driven turbo-supercharger built by General Electric, not mechanically driven off the crankshaft, driven by exhaust gas. The hotter the exhaust, the faster the turbine wheel spun, the more compressed air it forced into the engine. The beautiful trick, and Johnson understood this at a level that his competitors apparently did not, involved a feedback loop. As the aircraft climbed and ambient air thinned, the exhaust-driven turbine actually maintained its efficiency longer than a mechanical supercharger could, because the wastegate could be progressively closed to keep turbine speed high. The engine didn't know it had climbed. It kept producing rated power at altitudes where a Merlin or a DB605 had already started gasping. The penalty came in plumbing. Turbo-superchargers required intercoolers, ducting, wastegates, oil lines to lubricate bearings spinning at tens of thousands of RPM, and exhaust pipes routed from the engine to the turbine housing and then overboard. On a single-engine fighter, cramming all that hardware into a tight fuselage created a thermal and packaging nightmare. Johnson's twin-boom layout solved the problem with an elegance that bordered on the obvious. In retrospect, each engine sat in its own boom. Each boom carried its own turbo-supercharger behind the engine, its own radiator, its own exhaust routing. The pilot sat in a central nacelle between the booms, ahead of the wing. The guns, a 20mm Hispano cannon and 4 50-caliber Brownings, clustered in the nose, firing straight ahead without propeller synchronization. No convergence calculations, no harmonization headaches, point and shoot. The P-38 flew for the first time on January 27, 1939, at Marchfield, California, with Lieutenant Ben Kelsey himself in the cockpit. It climbed to 20,000 feet in well under 6 minutes. The exact time remains disputed. Lockheed's records say one thing, the Army's acceptance data says another, and a fire at the plant in 1941 destroyed some of the original test cards. What isn't disputed? The aircraft met the X-608 requirement with margin to spare, and it kept climbing past 20,000, like the air up there belonged to it. No European fighter in 1939 carried turbo-superchargers, not one. The British had experimented with them on the Spitfire and abandoned the effort. Too much heat, too many failures, and nowhere near enough room in the airframe. The Germans never seriously tried. Their engineering culture favored the mechanical supercharger, refined incrementally, and by the time the Luftwaffe recognized the altitude gap the turbo created, the war had already moved past the point where a clean-sheet redesign could catch up. The Americans didn't stumble into this advantage. A 27-year-old engineer in Burbank built it on purpose. So why didn't the Germans just build their own turbo-superchargers? They had the metallurgy, the engineering talent. Daimler-Benz employed some of the finest engine designers on the planet, men who'd built Grand Prix engines capable of sustained output at RPM levels that made British and American engineers nervous. BMW's radial division produced the 801 engine that powered the Focke-Wulf 190, a masterpiece of air-cooled design, compact, reliable, brutal at low and medium altitudes. The talent existed. The institutional will did not. Germany's turbo-supercharger program, and they had one, run through the DVL research establishment and contracted to manufacturers, including Hertz and TKL, never produced a flight-rated unit in meaningful numbers. Test rigs worked and prototypes flew, but production didn't follow. The reasons pile up in layers that tell you more about the Reich's war economy than about aerodynamics. Nickel and chromium, the alloying elements essential for turbine blades that won't deform at 1400 degrees Fahrenheit, sat on Germany's critical shortage list from 1941 onward. General Electric's turbo units used Hastelloy and other heat-resistant alloys that American industry produced by the ton. German metallurgists tried substitutes, ceramic coatings, alternative alloy formulations, and achieved turbine life measured in hours rather than the hundreds of hours GE's units delivered. A turbine blade that cracks after 12 hours of operation is a laboratory curiosity. One that runs for 300 hours is a weapon system. The gap between those two numbers contained the entire German altitude problem, compressed into a disk of metal spinning at 17,000 RPM in exhaust gas, hot enough to glow cherry red in daylight. What the Luftwaffe flew instead worked brilliantly, below a line drawn across the sky at roughly 20,000 feet. The Messerschmitt 109 G6, the most produced variant, carried a DB605AM engine with a single-stage two-speed mechanical supercharger. In high blower, its critical altitude, the height at which the supercharger could no longer maintain rated manifold pressure, sat near 22,000 feet under ideal conditions. Above that, power bled away at a rate of approximately 4% per 1,000 feet. A pilot pulling into a climb at 24,000 feet had already lost close to 150 horsepower compared to his performance at 20,000. At 28,000, the 109 still flew. It had a service ceiling above 38,000 in clean configuration, but it flew like a different airplane. Sluggish on the controls, mushy in turns, the engine delivering perhaps 60% of its rated power. The Focke-Wulf 190A, powered by BMW's 14-cylinder 801D2 with a single-stage two-speed supercharger plus a crude but effective fuel injection boost system, fared even worse at altitude. Its critical altitude in high blower barely touched 18,000 feet. Above 22,000, the 190 handled like a truck on ice. German pilots called high-altitude 190 flying, and I'm translating loosely from a Jagdgeschwader 2 pilot's post-war account, asking the machine to do something it resented. That assessment tracks with the performance curves. The 190's rate of climb above 20,000 feet dropped below 1,000 feet per minute. The P-38J, at the same altitude, sustained over 2,000, double the climb rate. Not a marginal advantage, a structural one, built into the physics of how each engine breathed. German engineers understood the problem with uncomfortable clarity. A 1943 Rechlin test center evaluation of captured P-38G components, one of the few intact turbo-supercharger assemblies the Germans got their hands on, produced a report that reads like a frustrated love letter to American manufacturing. The evaluators noted the precision of the turbine wheel balancing, the quality of the bearing seals, the elegant simplicity of the wastegate actuator. They also noted, with the dry candor of men who knew their own production lines, that replicating the unit would require retooling 3 separate factories and a supply of nickel alloy that didn't exist in the Reich's stockpiles. The report recommended continued development of mechanically driven two-stage supercharger systems as the practical alternative. Practical, not superior. The distinction matters. The Germans didn't choose their supercharger approach because it outperformed the American system. They chose it because they could actually build it. The DB605D engine, which entered production in late 1944 with a two-stage mechanical supercharger, pushed the 109's critical altitude up to about 26,000 feet, a real improvement. It arrived too late, in too few numbers, with reliability problems that kept Jagdgeschwader maintenance crews working through nights on engines that ate their own supercharger gears after 40 hours of operation. 260 P-38Ls rolled off Lockheed's Burbank line in a single month. The DB605D never achieved anything close to that production rate. The altitude gap didn't just cost individual engagements. It compressed German tactical options into a narrowing band of sky. A fighter force that cannot contest the airspace above 25,000 feet has surrendered the bounce, the diving attack from superior altitude that had been the Luftwaffe's signature move since the Condor Legion tested it over Guernica in 1937. Werner Milders built his tactical doctrine around altitude. Oswald Boylke's Dicta, sacred text of German fighter aviation since the First War, enshrined it. Always attack from above, always retain the energy advantage. Own the ceiling. By late 1943, over the skies of Western Europe, the ceiling belonged to Lockheed. The light up there looked different, a pale, washed-out blue that deepened toward violet at the edges of the canopy glass, the sun sharper and whiter than anything a pilot saw at 15,000 feet. P-38 pilots described the cold as the thing they remembered most. -40, -50 Fahrenheit, frost forming on the inside of the windscreen despite the defroster. The Allisons ran hot enough to keep the turbo-superchargers fed. The Germans couldn't get up there to argue about it. Smoke. That's what the bomber crews talked about. the black oily smear of flak bursts hanging in the air at 25,000 feet like stains on a window nobody could clean. October 1943, and the 8th Air Force had been bleeding over Germany for months. Schweinfurt, Regensburg, Stuttgart, names that meant columns of burning B-17s stretching across the sky in long funeral processions, 60 bombers lost in a single afternoon, 600 men gone before dinner. The problem had a shape everyone could see and nobody could solve. The fortresses flew at altitudes between 23 and 27,000 feet. Their little friends, P-47, Thunderbolts mostly, ran out of fuel and turned back at the German border. Beyond that line, the bombers flew naked into a defense system that had learned exactly how to kill them. Luftwaffe interceptors, 109 G6s from Jagdgeschwader 3 and 11, 190As from Jagdgeschwader 1, would orbit ahead of the bomber stream at 20,000 feet, well within their comfort zone, then pull up into slashing head-on attacks through the formation, close to 800 miles per hour of closing speed, a 2-second firing window, then dive away, regroup, climb back up, do it again. The system worked because nobody sat above the German fighters to punish the climb back. The P-38 arrived in the European theater like an answer to a question the 8th Air Force had been screaming since August. The 5th 56th Fighter Group, equipped with P-38Hs, flew its first escort mission from Nuthampstead, England, on October 15, 1943. The 20th Fighter Group followed in late December. The 364th and 367th Groups converted to Lightnings in early 1944. The numbers stayed small. The Pacific and Mediterranean theaters consumed most of Lockheed's production through 43. But the ones that showed up changed the arithmetic of altitude immediately. The German intercept controllers noticed it before their pilots confirmed it. Their own radar plots told the story. The escorts weren't staying level with the bombers. They flew above them, 2,000, sometimes 4,000 feet above the top of the combat box, weaving in lazy S-turns to keep their speed up, while the fortresses droned along at 210 miles per hour. A fighter sitting at 29,000 feet with turbo-supercharged engines producing full-rated power occupies a position that a 109 climbing from 20,000 feet cannot reach without spending 3 to 4 minutes in a sustained climb, minutes during which the German pilot bleeds airspeed, loses maneuverability, and presents a slow, nose-high target to an opponent looking down at him with a concentrated battery of nose-mounted guns. The bounce, the Luftwaffe's bread and butter, had been reversed. The P-38 owned the altitude. The German had to come up to challenge it, and coming up cost him everything Boelke's dicta said never to give away. Oberstleutnant Egon Meyer commanded Jagdgeschwader 2 on the Channel coast. A skilled tactician, 46 confirmed kills by early 1944, credited with developing the head-on attack against heavy bomber formations. Meyer adapted faster than most. His unit's tactical assessments from January and February 1944, preserved in fragmentary form through Luftwaffe quartermaster records, cross-referenced with British Air Intelligence translations, describe a shift in intercept geometry, forced specifically by high-altitude escorts. The old approach had been vertical: climb ahead of the stream, dive through it, extend below, zoom back up. Against unescorted bombers, this worked with lethal efficiency. Against a formation topped by P-38s holding 28,000 feet, the zoom climb became a death trap. Meyer's pilots reported, and this comes through the intelligence summaries, not direct memoir, that the fork-tailed fighters initiated dives from positions the 109s couldn't reach in time to counter. The diving P-38 accelerated through 400 miles per hour in seconds, carrying enough energy to slash through the German formation and pull back up to altitude without entering the low-speed turning fight where the 109 held an advantage. Meyer's solution looked pragmatic on paper. He pushed his intercept altitude down. Instead of climbing to 25,000 to meet the bombers head-on, his pilots began staging attacks from 18 to 20,000 feet, hitting the bomber stream from below and the side, accepting worse firing angles in exchange for staying in the altitude band, where the 109 still performed at near-peak capability. The trade-off cost accuracy against the bombers. It also conceded the entire upper hemisphere of the sky to the Americans without a fight. An irrelevant detail, but a striking one. Mayer's personal aircraft carried a non-standard paint scheme, a yellow and black checkerboard on the engine cowling, visible at distances where unit markings blurred into nothing. Whether this helped or hurt his survival odds is unknowable and beside the point. What matters is the pattern. Jagdgeschwader 2's altitude shift wasn't unique. Across the winter of 1943 into 44, Luftwaffe fighter units along the entire Western Front adjusted their engagement profiles downward. The Reichsverteidigung, the Reich Air Defense System, had built its intercept doctrine around altitude superiority. Radar would vector fighters above the incoming stream. Fighters would dive, attack, climb, repeat. The P-38 didn't defeat this system by shooting down every German fighter it encountered. It defeated the system by occupying the airspace the system required. Just as a castle becomes useless when the enemy holds the hill above it, the Luftwaffe's intercept geometry collapsed when someone else owned 30,000 feet. Egon Mayer died on March 2, 1944, shot down by American fighters near Montmedy. The records don't specify whether the aircraft that killed him carried one engine or two. Hans Philipp pulled his 109 into a vertical split S at 26,000 feet over Aachen, chasing a P-38 that had just rolled inverted and dropped its nose toward the deck. The Lightning vanished below him in a near-vertical dive, accelerating past 450 miles per hour indicated. Philipp followed, or tried to. What happened next entered Luftwaffe tactical lore through channels that moved faster than any official report. The fork-tailed fighter, somewhere below 20,000 feet and approaching 500 miles per hour, stopped pulling out. Its nose tucked further down instead of responding to backstick. The aircraft hit the ground. No flak, no gunfire, no mid-air collision. The P-38 killed itself. Word spread through Jagdgeschwader channels, with the particular speed reserved for good news about enemy weaknesses. The Americans had built a fighter that owned the sky above 25,000 feet, but couldn't leave it in a hurry. The flaw had a name, compressibility, though most German pilots who learned to exploit it never used the term. They described it in operational language. Push the Gabelschanze, the forktail, into a steep dive, and above a certain speed the elevator authority disappears. The nose tucks under. The pilot pulls back on the yoke and nothing happens. The faster the aircraft goes, the worse it gets. Lockheed knew about this before the Luftwaffe did. Test pilots at Wright Field had encountered the phenomenon as early as 1941 during high-speed dive tests, reporting a sudden and violent pitch-down that resisted full aft stick input. The aerodynamics involved shock waves forming on the wing's upper surface as localized airflow exceeded the speed of sound, a transonic effect that no wind tunnel in America could accurately model at the time. The P-38's thick wing, designed for structural efficiency and internal fuel volume, made the problem worse than it might have been on a thinner airfoil. Lockheed's fix arrived in stages, none of them fast enough for the pilots dying in the interim. Dive flaps, small surfaces under the wing that disrupted the shockwave pattern and restored pitch authority, entered production on the P-38 J-25 block in mid-1944. Before that, Lightning pilots in the ETO flew with a tactical restriction that read like a confession. Do not exceed indicated airspeed of 400 miles per hour in a dive, 400 miles per hour. A 109 in a clean dive could touch 500 without structural concern. The restriction meant that any P-38 pilot who initiated a diving attack from high altitude had to start his pullout early, bleeding energy, giving the German below him extra seconds to evade or reverse. It meant that a German pilot who dove away from a lightning engagement had a reasonable chance of escape if he pushed past the speed where the American dared not follow. The Luftwaffe figured this out through trial, error, and dead Americans. Jagdgeschwader 26's Oberfeldwebel Adolf Galland, 104 missions, 71 confirmed victories by war's end, described the tactic in a post-war interview with blunt pragmatism. When engaged by P-38s at altitude, split S and dive vertically. The fork-tails either followed and died, or broke off and let you go. Glantz didn't frame it as doctrine. He framed it as survival. The German pilot community absorbed the lesson with the desperate efficiency of men running out of advantages. Against the Lightning, dive. Against the Mustang, turn. Against the Thunderbolt, don't get caught slow. Against the Jug at speed, don't bother chasing. Each American fighter had a flaw. Knowing the flaw kept you alive for one more sortie. That knowledge didn't put German fighters back above 25,000 feet. The compressibility problem handed the Luftwaffe an escape route, not a weapon. A German pilot who dove away from a P-38 survived that engagement. He did not climb back up to contest the altitude the Lightning held. He did not intercept the bomber stream from above. He landed, refueled, and took off into the same tactical box he'd occupied before, 18 to 22,000 feet, attacking from below and the sides, accepting inferior geometry because the alternative meant climbing into airspace where his engine couldn't compete. The flaw in the P-38's wing saved individual German pilots. It changed nothing about who owned the ceiling. Just as a castle gate with a cracked hinge still controls the road beneath it, a P-38 with a compressibility problem still dominated any aircraft that couldn't reach its altitude in the first place. The 8th Air Force's loss rates tell the story in numbers that don't require interpretation. In October 1943, before significant P-38 escort coverage, bomber losses on deep penetration missions ran between 8 and 12% per sortie. By February 1944, with Lightning groups flying high cover, losses on comparable missions dropped to 4%. Still brutal, 4% per mission meant statistical destruction of an entire bomb group in 25 sorties, but half the October rate. The Germans hadn't stopped fighting. Their pilots still pressed attacks with a professionalism that commands respect across 80 years. They pressed those attacks from lower altitudes, at worse angles, with less time on target, because the airspace above them belonged to someone else. A Luftwaffe signals intercept from late February 1944, pulled from British ultra-decrypts and cited in the official Air Force history, records a JAG division controller instructing his fighters to avoid engagement above 7,000 meters. 7,000 meters, 23,000 feet. The controller didn't explain why. Everybody on the frequency already knew. 47%. That's the reduction in Luftwaffe head-on attacks against 8th Air Force bomber formations between October 1943 and May 1944, calculated from 8th Fighter Command's encounter reports and cross-referenced with Luftwaffe Jagddivision after-action summaries captured at war's end. 47%. The explanation had nothing to do with German pilots losing their nerve or flak taking over the defense. The attack profile that made head-on passes possible, the high orbit, the controlled dive through the bomber stream, the zoom climb back to altitude, the reassembly for a second run, required airspace that no longer belonged to the Luftwaffe. The FMS reports make grim reading if you're German. Generalleutnant Adolf Galland, inspector of fighters, and the closest thing the Luftwaffe had to an honest internal critic, dictated his assessment for American historians at a farmhouse in Schleswig-Holstein in 1945. His language carries the exhaustion of a man explaining a disaster he'd seen coming for 2 years. Galland described the introduction of turbo-supercharged American escorts as the moment the Reichsverteidigung lost what he called the initiative of altitude. A phrase worth pausing on, because Galland chose it carefully. Not altitude itself. The initiative of altitude. The ability to decide when and where to use the vertical dimension offensively. The initiative passed to the Americans, and it didn't pass back. Galland's post-war testimony tracks with what the POW interrogation files show at the individual level. Captured pilots from Jagdgeschwader 3, pulled from their aircraft over Belgium and northern France in the spring of 1944, told MIS interrogators a consistent story. They'd been briefed to engage bomber formations. They'd been told escort fighters would be present. They had not been told, or hadn't believed, that those escorts would be sitting 4,000 feet above the bombers with enough engine power to stay there indefinitely. One Feldwebel from the 3rd Gruppe, shot down on April 8, 1944, described his Staffelkapitan's pre-flight briefing as including the instruction to attack from below only, do not attempt to gain altitude over the escort. The interrogation transcript notes this without editorial comment. It didn't need any. The British had watched a similar altitude concession unfold 2 years earlier, though under different circumstances. During the 1940-41 Blitz, RAF night fighters struggled for months to reach the altitudes where Heinkel 111s and Junkers 88s operated, not because British engines lacked power, but because airborne intercept radar couldn't reliably acquire targets above 18,000 feet in early war configurations. The parallel isn't exact. The German daylight problem in 44 stemmed from engine limitations rather than sensor failures, but the operational result rhymed. A defending force that cannot reach the attacker's altitude fights on the attacker's terms every single time. Which brings us back to what those terms looked like over France in the weeks before D-Day. By May 1944, Luftwaffe fighter operations in the West had compressed into a tactical pattern that Boelke would have found unrecognizable. Intercept altitudes clustered between 15 and 21,000 feet. Engagement times shortened. German pilots spent less time orbiting ahead of bomber streams because orbiting at 20,000 feet meant exposure to diving attacks from P-38s and, increasingly, P-51s holding 27,000 and above. The preferred tactic became a single slashing pass from the beam or from below, followed by an immediate dive to the deck. No zoom climb. No second pass. Get in, fire, get out, go home. The Jagdwaffe had been reduced to a hit-and-run force in its own airspace, over its own territory, defending the cities it could no longer shield. A sensory detail from a Jagdgeschwader 11 pilot's memoir lodges in the mind. He described looking up through his canopy glass during a mission over Brunswick in late April 1944 and seeing contrails, white threads scratched across a sky so deeply blue it looked almost black at altitude, drawn by aircraft he could not reach. He counted 8 trails. They moved in pairs, weaving slowly, patient as vultures. He knew what they carried. He knew what happened to pilots who climbed toward them. He turned his attention back to the bombers below and made his pass at 19,000 feet, firing a 2-second burst into a B-17's No. 3 engine nacelle before rolling inverted and splitting for the deck. The contrails stayed above him the entire time, undisturbed. That pilot survived the war. Many didn't. Luftwaffe fighter pilot losses between January and June 1944 exceeded the total operational fighter pilot strength the force had carried on January 1st. They lost more than 100% of their starting roster in 6 months, replacements dying as fast as they arrived, experienced men ground down sortie by sortie. The causes multiplied beyond the altitude problem alone. Fuel shortages cut training hours. American fighter sweeps ahead of the bomber stream caught German formations during assembly before they'd even reached intercept altitude. The P-51B Mustang, arriving in force by March, extended the escort umbrella to Berlin and beyond. None of this erases the specific contribution of the turbo-supercharged high cover that the P-38 provided during the critical winter months when the Mustang hadn't yet arrived in numbers. The Lightning held the ceiling during the period when holding it mattered most, the transition months between the unescorted bloodbaths of late 43 and the overwhelming fighter superiority of mid-44. Galland used a phrase in his FMS deposition that the American interviewer underlined twice. We lost the war in the air above 25,000 feet before we lost it anywhere else. The interviewer's underlining survives in the National Archives copy. His reasons for emphasizing it do not. But Galland's arithmetic needed no annotation. The Luftwaffe stopped climbing because climbing meant dying. The Americans owned the air up there because they'd built engines that breathed where German engines starved. Everything else followed from that single thermodynamic fact, spinning inside a turbine wheel at 17,000 RPM. So who actually won the ceiling above 25,000 feet? Not Kelly Johnson, though he built the machine. Not the pilots of the 5th, 56th, or the 20th Fighter Groups, though they flew it into airspace where German engines choked. The ceiling belonged to a specification, a piece of paper. Circular Proposal X-608, dated February 1937, written by lieutenants and captains at Wright Field, who would never fly the aircraft they demanded into existence. They asked for a fighter that could reach 20,000 feet in 6 minutes and operate at full combat power above 25,000. They asked for it because the Army Air Corps had decided, bureaucratically, institutionally, without drama, that the next war would be fought at altitudes where current fighters couldn't function. The specification didn't mention turbo-superchargers by name. It didn't need to. The performance numbers made them mandatory. No naturally aspirated engine on Earth could meet those climb and altitude requirements in 1937. Lockheed's proposal, the only one that met every threshold, built the turbo-supercharger into the airframe's DNA from the first sketch. The Germans never wrote that specification, not because they lacked the engineers, not because they couldn't see the problem, because their procurement system asked different questions. The Reich's Luftfahrtministerium, the RLM, Germany's Air Ministry, issued requirements based on tactical roles defined by existing doctrine. Fighters intercepted bombers at the altitudes bombers flew. Bombers flew at 15 to 20,000 feet. Therefore, fighters needed to perform at 15 to 20,000 feet. The logic held a circular trap that nobody inside the system recognized until American heavy bombers started crossing the channel at 25,000 feet, with escorts sitting 4,000 feet above them. By then, redesigning the Daimler-Benz 605 or the BMW 801 around a turbo-supercharger meant re-engineering the nacelle, the exhaust routing, the cooling system, the fuel delivery, a 2-year project in peacetime, an impossibility for a nation whose factories burned under round-the-clock bombardment. The conventional narrative gets this wrong. People treat the P-38's altitude dominance as an engineering triumph. Johnson's genius, Lockheed's innovation, American mechanical ingenuity, all true, all incomplete. The deeper story sits in a filing cabinet. American military procurement in the 1930s operated through a specification culture that no other Air Force replicated. The Army Air Corps wrote requirements, documents that described performance envelopes, not aircraft. They told manufacturers what the airplane had to do, not how to do it. X-608 didn't say, build a twin-engine fighter with turbo-superchargers. It said, reach this altitude in this time at this speed with this armament. The solution space remained open. Johnson chose twin engines and turbo-superchargers because the math demanded them. A different engineer might have proposed a different configuration, and several did, none of which met all the numbers. The specification filtered for the right answer without prescribing it. That filtering mechanism, boring and procedural and invisible to anyone who prefers stories about test pilots and dogfights, produced the aircraft that pushed the Luftwaffe below 23,000 feet. The British came close. Their Spitfire Mark VII, pressurized and fitted with a 2-stage supercharger, reached comparable altitudes by 1943. Superb aircraft, built in small numbers for a specific high-altitude intercept role, not as a general-purpose fighter expected to escort bomber formations deep into enemy territory. The difference between the British approach and the American one mirrors the difference between solving a problem and preventing one. The RAF adapted the Spitfire upward when the threat demanded it. The USAAF specified the altitude requirement 7 years before the threat materialized. Foresight versus response. The American version scaled. Lockheed built 9,923 P-38s between 1941 and 1945. Of those, the Army Air Forces accepted approximately 3,000 for the European and Mediterranean theaters. After VE Day, surviving Lightnings faced the same arithmetic every wartime aircraft confronts. Peacetime has no use for 10,000 single-purpose machines. Most went to RFC, Reconstruction Finance Corporation, smelters at Kingman, Arizona and Walnut Ridge, Arkansas. Rows of twin-boomed fighters sitting wingtip to wingtip in the desert sun, canopies still smeared with oil from their last missions, waiting for the cutting torches. The aluminum went back into the commercial supply chain. Pots, pans, car parts, screen doors. a turbo-supercharger housing that had pushed exhaust gases through a turbine wheel at 1400 degrees Fahrenheit above Schweinfurt became, eventually, somebody's lawn furniture. 26 complete P-38s survive today. The National Air and Space Museum holds a P-38 J-20 on loan, restored in the markings of the 475th Fighter Group, a Pacific theater unit. The Planes of Fame Museum in Chino, California, maintains a flying example, one of only 2 airworthy Lightnings left on Earth. Its Allison V-1710 engines still turn over, still feed exhaust into the turbo-supercharger housings, bolted to the tail booms, still produce the high-altitude power that specification X608 demanded 89 years ago. When that aircraft climbs through 25,000 feet at an airshow, which it almost never does because the insurance alone would bankrupt a small country, the turbines spin up to the same RPM they held over Festung Europa in the winter of '44. The air thins, the superchargers compensate, and the manifold pressure holds steady. Somewhere in the National Archives, filed under Record Group 18, Army Air Forces, a maintenance log from the 20th Fighter Group at Kings Cliff lists a P-38J, serial number 42-67762, as surveyed and struck from inventory, August 1945. Reason given: excess to requirements. The turbo-superchargers had done their work. The ceiling had been won. The after-action report listed it as surplus.